this question, matrix A is AIG and of order 3 such that a condition is given which is valid for all the values of ing, and we need to find the matrix of the value of this matrix. So how to do it? First, find the matrix A, that is A11, A12, A13, A21, A22, A23, A31, A32, and A33. Now, condition is given for aij. Just put these values in ing. We can find the matrix. So now here a11, both I and j are 1. So if we put, we'll get 2 power 1 minus 1, and next 2 power 2 minus 1 as j is 2, 2 power 3 minus 1. Here 2 power 1 minus 2 as j is 1 over here, 2 power 2 minus 2, 2 power 3 minus 2. Here 2 power 1 minus 3, 2 power 2 minus 3, 2 power 3 minus 3. Now we'll get as 2 power 0, 1, 2 power 1, 2, 2 square, 4. 2 power minus 1, that is half, 2 power 0, 1, 2 power 1, 2. 2 power minus 2, that is 1 by 4. This is 1 by 2, and this is 1. So this is the matrix A. So let's find A square and observe whether we are getting something pattern or not. So how to do A square? So using matrix multiplication. Multiply this row with this column, you will get it as 1 plus 2 times of half plus 4 times of half, sorry, 4 times of 1 by 4. And next 1 into 2, 2, 2 into 1, 2, 4 into 1 by 2, that is 2. Next 4 into 1, 4, 2 to the 4, 4 into 1, 4. 1 by 2 into 1, 1 by 2 plus 1 plus 1. Again 1 plus 1 plus 1. Next 4 into 1 by 2, that is 2 plus 2 plus 2. Next 1 by 4 plus 1 plus 1 by 4. Next 1 by 2 plus 1 by 2 plus 1 by 2. Next 1 plus 1 plus 1. The final will get it as 1 plus 1 plus 1, that is 3. 2 3 is 6 and 12 over here. 2 plus half, that is 5 by 2, and 3 over here, 6 over here. 1 by 2 plus 1, that is 3 by 2. Here 3 by 2, and here it's 3. Take 3 common. So here it becomes 1 by 2, and you will get it as, here also it becomes 1 by 2. You'll get it 3 by 2 over here. And here you'll get 1 by 4. You'll get 3 by 4 over here. Now take 3 common from this. You will get 1, 2, 4, 1 by 2, 1, 2, 1 by 4, 1 by 2, and 1. So here this is nothing but matrix A. Now we can write it as 3 into A. Similarly, A cube can be written as 3 square A. So here A cube, here it's 3 square A. Now we can write A power 4 as 3 cube into A. So for so on, A power 10 becomes 3 power 9 into A. Now from the LHS, it is A square plus A cube so on, plus a power 10. Now we can write it as 3 square into a, 3 cube into a. Sorry, first it is 3 into a plus so on, 3 power 9 into a. Take a common from this and remaining is 3 plus 3 square, so on till 3 power 9. It's following geometric progression. So we can write it as a into 3 into 3 power 9 minus 1 by 3 minus 1. So it becomes 3 power 10 minus 3 by 2 into a. So first option is the required answer for this question. In this question, matrix A is given and alpha and beta ka condition is given. We need to find the value of alpha plus beta. So first find a square, that is 1, 2, minus 2 into minus 5 into 1, 2, minus 2, minus 5. When matrix multiplication is possible, so when we do it, here it becomes 1 minus 4, 2 minus 10, minus 2 plus 10, minus 4 plus 25. It is nothing but minus 3 minus 8, 8, 21. So let's use the condition given. It is alpha a square. So it becomes minus 3 alpha, minus 8 alpha, 8 alpha, 21 alpha, plus beta into a. That is beta, 2 beta, minus 2 beta, minus 5 beta is equal to 2 into I, that is 2, 0, 0, 2. Now just add and equate it. It becomes minus 3 alpha plus beta. Just add the corresponding elements. 8 alpha minus 2 beta, 21 alpha minus 5 beta. Equate it with 2, 0, 0, 2. Now we'll get as minus 3 alpha plus beta is 2 and minus 8 alpha plus 2 beta is 0. So from this two equations, we'll get alpha as 2 and beta as 8. You can put these values in this matrix and cross-check with the answers. We'll get the same. So we need to find alpha plus beta, that is 10. So 10 is the required answer for this question.